Okay, so you want to own a drone delivery network. From the sidewalk, the business looks almost absurdly simple. Someone opens an app, taps a few groceries or a takeout order, and a small aircraft appears over the neighborhood. It lowers the package into the yard. No driver hunting for parking, no car stuck at a light, just a quiet little machine and a very fast handoff. Walmart says its drone network has completed more than 1 million drone deliveries across 66 stores in 4 states and 5 metro markets. In the same release, Walmart reported a 23-minute average delivery time and a fastest delivery of 4 minutes and 44 seconds. That is the dream you are buying, a faster last mile. But the thing you would actually own is not a handful of drones. It is a local operating system that has to stay aviation ready every single day. There is a physical layer, a merchant shelf, an order system, a launch site, and the equipment that gets an aircraft out and back. If that layer is not ready, there is nothing to deliver. Then there is the invisible layer: connectivity, remote supervision, insurance, operating procedures, and an FAA-compliant way to put an aircraft over somebody's neighborhood. If that layer fails, the aircraft stays on the ground. The customer sees one completed delivery. You inherit everything that has to be ready before that customer ever taps "Place order." And that means the first question is not, how quickly can the drone fly? It is, what invisible machine has to work between the tap on the app and the package at the door? A drone delivery network begins with a promise that sounds like software: click, match, dispatch. But the actual service behaves more like a small airport connected to a local warehouse. Item eligibility. The merchant has to confirm that it is eligible. It has to fit the payload rule, the packaging rule, and the delivery method. That filter decides which revenue you can even accept. That sounds trivial until you remember that a bag of fries, a bottle of medicine, a fragile grocery item, and a hot coffee do not create the same operational problem. Dispatch has to decide which base can serve the order, which aircraft is available, which route is appropriate, whether the delivery area is open, and whether weather, airspace, communications, and the aircraft's condition all allow the mission to begin. Every constraint removes available capacity before a customer ever sees the service. Amazon's Clay site proposal planned for 15 to 20 ground staff, with each monitor overseeing up to 6 aircraft. That was a proposal stage staffing plan, not a completed operating model. The aircraft is inspected, charged, loaded, and released. During the flight, a remote operations system has to monitor it. If weather changes, communications degrade, a delivery point is unavailable, or the mission needs to be aborted, there must be a procedure for returning, recovering, and documenting the aircraft. After the handoff, the work is not over. The aircraft must be checked, recharged, logged, and made available for the next mission. Batteries age and parts wear, so maintenance cannot be saved for a convenient day. Maps and software change, so the operating picture must stay current. Remote operators need training, while maintenance records and incident processes must remain current because a network has to show that it can keep operating safely. Job sites put remote operator or monitor roles at roughly $50,000 to $59,000 a year, and drone maintenance technician roles at roughly $60,000 to $67,000. Those are small sample job site estimates, not a uniform market price for delivery network monitors or technicians. Merchant handoffs fail and customers enter bad delivery instructions, so someone needs an answer for the exception. A network only looks automatic because people and systems have already decided what happens when it is not. The scale of the operating problem is easy to hide with a beautiful flight video. In one FAA environmental analysis scenario for Chicago, the agency considered up to 1,000 Mk-30 delivery flights per PADDC operating day. Notice the word flights. That is not a claim about 1,000 orders, and it is not a claim about 1,000 completed deliveries. It is an example of the operational volume regulators may need to analyze. A reported Amazon Pontiac site gives a different, deliberately local view of physical operations. 14 drones, more than 100 deliveries per day in total, a 7.5-mile service radius, and a 5-pound package limit. Those figures do not tell us what every base can do. They tell us that even one real-world site has a fleet, a service boundary, and rules about what can move through it. Then there is the permission layer. FAA Part 135 is a certification pathway used for package delivery, not a blanket right to fly BVLOS anywhere. The FAA's Part 135 process has 5 stages and 3 gates. A network still needs the applicable operating permissions and airspace treatment. Those determine whether a route can be flown as planned. It also needs site conditions and ongoing compliance, because a right to operate has to remain in force after launch day. That is the hidden machine. It is not a vending machine with propellers. It is a chain, and its throughput is limited by whichever link breaks first, not by how fast the fastest drone can fly. Which brings us to the first bill. Before a base is busy, it has to exist. The physical base, a host site, pads, charging, and loading. Until those pieces are in place, the base cannot turn an order into a launch. Safety and compliance. Safety zones, reliable connectivity, certification work, and the procedures that let the site operate. These do not make the service look faster, but without them, the service may not be allowed to run. Industry estimates often put the full Part 135 certification process above $100,000 once legal work, consultants, operating manual development, and safety audits are included. Specialist consultants run roughly $87.50 to $175 an hour, often on a project or retainer basis, and certification commonly takes 12 to 18 months. The FAA does not publish a standard price list, which is why each company's total certification bill has to be negotiated. Fleet assets: aircraft and spares, maintenance capability, batteries, and insurance. That is the stack that keeps one grounded aircraft from turning into a grounded operation. Basic commercial drone liability coverage is quoted at roughly $466 to $1,131 a year, depending on liability limits from $0.5 million to $2 million. Delivery fleets are higher risk. Coverage starts around $4,000 a year and requires a custom policy. A DJI Flycart 30 has a public sticker price of about $16,590 before the winch, batteries, charging station, and other accessories. It is a comparable delivery drone with a public quote, not the aircraft cost for Zipline, Wing, Amazon Prime Air, or Mana. Those companies have not made their own aircraft purchase prices public. The ramp includes remote operations training, merchant integration, and working capital while the site builds demand. Those costs arrive before the order volume that is supposed to cover them. A local report cited roughly $750,000 to build one Zipline site at a Bedford Walmart location. That is useful because it makes the base feel real. That one local example does not mean every drone base costs $750,000. Similarly, Papillion began with 12 drones and planned about 30 jobs. Planned jobs are not completed jobs. And one city's launch conditions are not an industry template. The deeper point is the split between fixed readiness and variable utilization. The site, systems, insurance, and compliance exist on a quiet Tuesday just as surely as they do during a lunch rush. Baseline remote operations and much of the organization are waiting too. Those readiness costs are there before a single order arrives. Variable costs rise as aircraft fly, recharge, wear, and require mission support. But the fixed stack is already waiting. Public sources do not provide a complete picture of what it actually costs to run a base. We do not have a full public view of the upfront asset bill, aircraft acquisition, battery replacement, and the equipment needed to support them. We also do not have a complete ongoing cost picture for maintenance, insurance, remote supervision, and depreciation. And the commercial side remains unclear. Merchant commissions, platform splits, and per-delivery profit are not publicly disclosed in a complete, comparable form. That gap matters. It means you should not take a consumer drone price, multiply it by a fleet size, and pretend you have valued a delivery network. Now that we know what the system has to carry, we can finally ask the revenue question. Who is paying to cover it? The household is the user, but the economic customer can be more complicated. A merchant wants access to nearby customers. A delivery platform wants a faster fulfillment promise. A flight operator supplies compliant aerial capacity. In a more integrated model, the retailer, membership program, ordering surface, and delivery system may sit closer together. That can reduce the number of handoffs between the customer and the aircraft. In a partner model, those functions are split, so the economics have to be shared as well. DoorDash announced wing delivery for eligible customers around Charlotte Arboretum, within about a 4-mile area. That arrangement illustrates the structure. Participating merchants supply items, DoorDash provides demand and checkout, and Wing performs the aerial movement. But the price on the checkout screen is not the same thing as operator revenue. In Papillion, Amazon reportedly charged Prime members $2.99 per delivery and non-Prime members $4.99, with qualifying Prime orders above $50 free. Public sources do not disclose the full platform, merchant, and operator split. So the real product is not a drone ride for one burrito. It is local delivery capacity that stays legal and ready, capacity that merchants and platforms can actually use. The consumer fee might support the system, or it might be a marketing lever, a membership benefit, or a fraction of a broader commercial arrangement. We still cannot see how much of that money the operator actually keeps. And even a strong commercial agreement does not solve the next problem. It only pays if enough suitable orders recur around the same base. A wide circle on a service map is not automatically an economic territory. Homes must be close enough, orders must be frequent enough, and items must be eligible enough to use the aircraft. The base needs overlapping merchant supply, platform demand, and repeat customer behavior. Zipline says its first Dallas point took 10 weeks to reach 100 deliveries per day, while later stations reached that threshold in 2 days. The useful lesson is not that 100 deliveries per day is the magic number. It is that site ramp-up is a real variable, and it can change when an operator has learned how to launch the next location. Wing says its top 25% of ordering customers order 3 times per week. That is evidence that some customers can form a habit. It is not evidence that every suburban household has become a drone customer. Density is the hidden financial engine. More suitable completed deliveries can spread the same base's fixed readiness burden across more units. But density is also the trap. A base can have a large theoretical coverage map and still have too few qualified orders. In that case, the aircraft wait while the site, systems, and compliance bill continue. This is why mature operators do not treat every base as an isolated gadget. They try to make one compliant operating stack serve a network. A base can draw eligible inventory from several merchants and be surfaced through partner ordering systems where contracts permit. That gives the site more ways to find suitable demand. It can also reuse dispatch software, training, maintenance knowledge, launch design, and operating data across locations. That means the next location can start with a playbook instead of starting from zero. The DoorDash and Wing arrangement is one example of connected demand inside a defined local service area. Zipline reports more than 2 million commercial deliveries, 20 million plus items, and 125 million plus autonomous commercial miles. Those numbers do not prove profitability. They do show why network learning matters. Deliveries, items, and miles each create different operating experience. Mana plans up to 40 operating bases in the United States and Europe. That wording matters. A plan to deploy bases is not 40 bases already producing revenue. Capital and expansion announcements tell you that companies are trying to build operating positions. They do not tell you that each position has already reached density or profit. And even the best connected network has bad days. Weather is not merely a cloudy backdrop. It changes the number of flying windows a base can use. A lunch rush that arrives during an unsuitable weather period does not wait politely for the aircraft to return. orders move to a car, get delayed, or disappear. The base may be available for part of the day, but miss the specific hours when merchants and customers are most valuable. That turns weather from a single canceled mission into a utilization problem. The fixed system remains ready, but fewer completed deliveries pass through it. Technical and safety events can be more persistent. An aircraft issue may begin as one inspection, but it can lead to extra checks, changed maintenance practice, a smaller available fleet, or a more conservative operating posture. A safety incident can trigger scrutiny from the operator, host site, regulators, and public, not just remove one flight. Community pressure follows its own escalation path. A neighbor may first complain about sound, frequency, or aircraft over a backyard. Then, meetings, petitions, or zoning reviews can turn an operating detail into a reputational and site risk problem. Local acceptance is an operating input like merchant participation and weather. A technically capable site can still face conditions that reduce when, where, or how often it operates. Demand has a pressure cycle too. A base built around lunch, weekend groceries, or a particular merchant mix may see those patterns soften. Merchants leave, promotions end. Seasonal behavior can make the same fixed stack look efficient in one period and stranded in another, which is why a large service map and a successful launch week are not enough evidence of durable economics. Regulatory and site authority conditions can add another layer. BVLOS package delivery remains subject to case-specific FAA operational authorization and conditions. The FAA's 1,000 flight environmental scenario is a maximum analyzed proposal, not guaranteed throughput. Public, comparable operator-wide interruption rates for weather, incidents, community opposition, or regulatory restrictions are not available. So we should not manufacture a downtime percentage. The mechanism is enough. A good business can still go bad when interruptions cut utilization faster than fixed commitments decline. Customers experience availability. If the app says unavailable, they choose another option. The owner still has the site, procedures, insurance, equipment, and people. That one-sided risk, where bad things happen fast but fixed costs don't disappear, is the real stress test of a drone delivery network. It also creates a sequencing problem. You cannot wait for density before building the compliant system, because the system is what lets you accept demand. But you cannot know whether it earns an adequate return until demand uses it repeatedly through good weeks and bad ones. The useful leading indicators are not a single flashy flight. Suitable merchants need to be connected to the base, and eligible customers need to come back. That tells you whether repeat demand may be forming. System availability matters too. Can it stay available without too many operational declines? That tells you whether demand can actually turn into completed deliveries. Timing matters as well. Does demand arrive in the hours when the fixed stack is already ready? That is when the base has the best chance to make its readiness cost work. Let's put honest numbers on one local base and run it through a good year and a harder one. In the good year case, assume 330 operating days, 120 completed deliveries per operating day, and $8 of blended retained revenue per completed delivery. That produces 39,600 completed deliveries and $316,800 of delivery-related revenue. Assume $210,000 of fixed annual readiness cost and $2.25 of variable cost per completed delivery. Variable cost is $89,100, leaving a simplified contribution of $17,700. Now, the harder year. Assume 300 operating days, 55 completed deliveries per operating day, and $7 of blended retained revenue per completed delivery. That produces 16,500 completed deliveries and $115,500 of delivery-related revenue. Fixed readiness still sits at $210,000. Assume variable cost rises slightly to $2.50 per completed delivery, or $41,250 annually. The simplified contribution becomes negative $135,750. That is operating leverage. The same fixed base, hit by lower utilization and slightly weaker retained revenue, swings from a small profit to a real loss. So, should you own a drone delivery network? Not because a drone can fly over a house. In 2026, that part is no longer the interesting question. You should only want to own one if the local operating position can stay legal and durable through bad days, not just launch day. You need merchant and platform connections that bring suitable orders to the base. You need the invisible system to stay safe and ready when those orders arrive. And you need enough repeat local demand to carry the base's fixed burden through bad days as well as good ones. The drone is the visible object. Compliant density is the business. And that is the economics of owning a drone delivery network.